Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe we have tried, so let's start. Now look at the question. Which of the following alkene is most stable? Stability of alkene, 4 alkenes are given. So here, in order to find out the stability of alkene, now we need to understand what is the reason for stability of any alkene. Answer is hyperconjugation. How hyperconjugation is decided? By the number of alpha hydrogen. So if you look at this is an alkene, if I say this is actually propene, okay, this is a CH double bond CH. Now the CH, this is the sigma bond. This sigma bond pair will be delocalized into the pi star orbital. This, by the way, how does the pi star looks like? The pi star looks like this. By the way, pi star means opposite symmetry. Okay, means no overlap. And there is a CH sigma. Okay, so this 2 electron in the sigma bond is delocalized in this pi star orbital. And because of this delocalization, some kind of stabilization is obtained. And you can see this MO diagram. How? So this is the CH sigma bond. It is actually interacting to the pi star of carbon-carbon double bond, as I told. So there is an overlap. What happened? There is a lower energy orbital, or it is a bonding molecular orbital formed by in-phase overlap. Okay, here the electron comes, and this is, you may say, anti-bonding molecular orbit produced because of out of phase overlap. And this ABMO is higher energy, BMO is lower energy. That's why BMO occupies electron. So in conclusion, say electron is promoted from comparatively higher energy level from here to the lower energy level because of this overlap. I want to say that stability of an alkene depends on the number of hyperconjugation, means number of alpha hydrogen. If more number of alpha hydrogen present, more number of hyperconjugation, then it will result higher extent of stability. Okay, so this is the main concept we should remember before solving the question. Now if you look at here, this option 1, so the next carbon, this is alpha carbon, only one hydrogen, so one hyperconjugation possible. If you say here this is alpha carbon, this is also, so there are 2 hydrogen, there are also 2 hydrogens, so total 4 hydrogens are present, 4 hyperconjugation. If you look at here only 1. Okay, by the way, if you look at both A and C, it's similar, so do not get confused. Now if you look at option D, so this is alpha, this is alpha, this is alpha, here 3. If you look at here also 3 alpha hydrogen, means 3 hyperconjugation, here 2, so total 8 hyperconjugation possible here. So the logic, higher the number of alpha hydrogen, higher will be the number of hyperconjugation, which will result higher the stabilization. So these will be the right answer. Now if you get this question in your exam less than 30 seconds, how could you solve? You need to check how many alpha hydrogen present. So at the beginning you should cancel out, sir, this option A and option C both are same, so you don't need to think about 4 options. Now if remember one thing student, these one and these one, these are terminal alkene. Generally terminal alkenes have lesser number of hyperconjugation compared to this one is internal alkene. Check here 2 plus 2 4, in this case 1, and in this case 8. Quickly you have to think, and for that purpose you need to do lots of practice. Okay, so in conclusion, whatever you have learned, that hyperconjugation is an electron delocalization phenomena by the interaction between the pi star orbital of alkene, which is actually acting as an electron acceptor, and the sigma of CH bond, means alpha carbon hydrogen bond. By the way, very often student get confused, sir, next one can't do, this one no student, they cannot participate. Beta, gamma, those hydrogen cannot participate because such kind of overlap will not be possible with them. So that's why only alpha hydrogen can participate in hyperconjugation. And the second point, the stability of alkene depends on the number of hyperconjugation. Higher the number, higher will be the stabilization. Now if you ask me, sir, can we prove it? Yes, you can prove it by heat of hydrogenation condition. Final products for every case will be same. Okay, so we'll discuss in some other videos. So this is the end of today's discussion. Thanks for watching. See you in our next video. Bye bye.